generally, it's so there's cartonization and there's cartonization. There's multiple levels of cartonization essentially, right? It's generally pretty simple to hack together a cartonization prototype, right? Like you just, given the weights, width, length, and heights of items, and then, you can, if you treat items as water, you can kind of like make a sort of heuristic on like, given a set of items, this is the box it should fit in, but there's not much certainty there. This is called like liquid fill cartonization. And that's kind of the cartonization that like a lot of, let's say, warehouse management systems would have, because warehouse management systems are going to run into cartonization at some point, right? Their customers need to make decisions about boxes. So warehouse management systems generally build some feature for that. But this liquid fill cartonization is not really that accurate. Like once you have oddly shaped items, long, flat, or whatever, then this completely breaks down. And so then you need to to really make this useful and dependable, make this 99%, 99.5, 99.8% accurate, i.e., an order is, the decision that the cartonization engine says is implementable by the person actually doing the packing. To achieve those like high levels of accuracy, you need a smart, really smart and really performant 3D engine that's able to like actually play the 3D Tetris and like actually make a 3D solution of the order. And you also and that's just like 3D Tetris, and there's levels there too. There's 3D Tetris just looking at items as cuboids, but sometimes certain items are can stack into each other. T-shirts can fold, they have certain dimensions, but like you can kind of fold them so they kind of behave like water. Then certain items can like stack onto each other, like baseball hats, right? A baseball hat has some sort of a cuboid approximation, but like if anyone who ever packed a baseball hat knows, you can grab multiple baseball hats and kind of fold them into each other, and that like reduces the volume of the pack, right? So that's the thing. There's also this thing where maybe you're shipping a mug and a golf ball, right? And they have dimensions, but that golf ball can kind of be put in that mug if needed, right? So then like there's a certain nestability of items, and these are all tricks that these are really hard mathematical problems, and they can save a lot of money. Like a smart cartonization engine that understands these nuances has the potential to save a lot of money for a company that uses it, right? But that's again like another step on top of just the 3D cartonization that to really achieve like 99.5% accuracy, that's what the cartonization needs to have, and it's really hard. That's why companies like Perseus exist, because like AWMS is never going to have the time and the engineering resources to go this deep, right? It's a really deep rabbit hole that it's an entire company to just like solve this one problem very well, and that's why we exist.